Hello class, this is a video tutorial on differentiating the logarithmic functions. At the most basic, the derivative of f of x equals ln x. Now recall that this actually means log base e of x, and this is only true for x is greater than 0, so we can't find the tangent values less than 0 or at 0. Well, we'll get into that in a bit later. But if we have the function ln of x, or log base e of x, its derivative is 1 on x. This is called the reciprocal function. But in general, if we wanted to find the derivative of f of x equals ln of some function of g, derivative of this is the derivative of g of x over the function g of x. Or even more simply, if we're given f of x equals ln u, f prime of x equals u prime on u. And this is only true for log base e, or ln. Okay, let's do an example of a few of these, because looking at this sometimes is very confusing. So let's get straight to it here. Let's say we want to differentiate this. I normally don't do this one for simple expressions such as this. Okay, but I'll demonstrate to you to make it even more simple for us to understand. So for this, u is going to be the expression of the natural log. So 3x plus 4. U prime is just 3. Now that we have this, y prime, right, we can summarize this as u prime on u. Substituting our values, well, u prime is 3 on 3x plus 4. It's very simple, just as that. So we went from ln of this value here, its derivative is 3 on 3x plus 4. Now I'll demonstrate to you how I would do this without this layout, although this is, there's nothing wrong with doing it this way. So for this, I'll demonstrate to you how I would normally derive this. Differentiate this. F prime of x is equal to, I leave the numerator blank, I go something over 5 minus half x. Now I take the derivative of my expression, half x, well, the derivative of that is negative half. And I can just leave it as, just as that. But if we wanted to, and we're required to, make this a little bit neater, this would actually be, if we factor out half, that's half times 1, negative 1 on 5 minus half x. Top times top, that gives us negative 1 on the numerator. Bottom times bottom, that's 10 minus x. That's 2 times 5, 2 times negative half. So the derivative f prime of x is equal to this expression there. Let's do this one more time. For this, I would actually do full set out. So u is the inside of the ln, so that's x squared plus 2x. U prime is 2x plus 2. Now the derivative of this, let's just label this as g prime of x. Well, that's the derivative of this first one. That's 2x plus 2 over u, which is x squared plus 2x. And don't forget about just separate terms that you can derive using just normal power rules. So this is 3x squared. All other differentiation rules apply, but they actually may become slightly more difficult. So for this is a product rule. So for this, I would go u is equal to x squared, u prime, that's 2x. V is ln of x, v prime is 1 on x. The product rule states y prime is u v prime plus u prime v. Substituting all my values correctly, y prime is u times v prime, that's x squared times 1 on x. So if you think about that, that's x squared times 1 on x. Those cancel, leaving us with just x by itself, plus u prime is 2x times ln of x. And there is our derivative. Gets much more difficult when we have the quotient rule. So here we go. I'm going to let u equal ln of 1 plus x. The derivative of this, u prime, is over 1 plus x. I take the derivative of x here, so it's 1. V is x squared, v prime is 2x. Now the quotient rule, it's f of x, so f prime of x is given as, and I'll show you a little trick of how I remember this. That's u v minus u v over v squared, and the derivatives I just put on the outside like this. So this means it's u prime v. Okay, here's where it gets very tricky. So f prime of x is equal to u prime times v. That's going to be x squared on 1 plus x. So that's done with this one. Minus u times v prime. So I'm going to leave this as 2x ln of 1 plus x. This is going to be all over x squared, all squared. I'm going to separate these into two separate fractions. This is going to be x squared on 1 plus x divided by x to the power of 4 minus 2x ln of 1 plus x divided by x to the power of 4. In case you're wondering how I did that, because this one here, that is u prime v over v squared minus u v prime on v squared. So I separated that term there. This will become x squared on 1 plus x times 1 on x to the power of 4 minus 2x ln of 1 plus x all over x to the power of 4. I'm just going to make some more space for myself here. Crossing off values, 4 gets rid of this, leaving us with 1 on, so this should be 2 there, 1 on x squared, 1 plus x. That's my first term, minus, should be 3 remaining here. That's 2 ln of 1 plus x, x cubed. I'm going to leave it right there. So hopefully that didn't scare you too much, but the main idea I hope you took from this is the derivative of ln of x is, going again, is the same expression with the numerator being the derivative of the denominator. And just different applications of it to the product rule and the quotient rule. Hope to see you in the next video where I do a few more examples right here. Hope to see you then. Best of luck.